And now we have the last part of our discussion on simple circuits, wherein we look at a couple of more examples. We have examples part 2. Okay, so sample problem number 3. In the given circuit, determine the current passing through each resistor. So passing through the 3 ohm resistor, you have I1. Passing through the 6 ohm resistor, you have I2. And passing through the second 6 ohm resistor, you have I3. The direction of the currents are already indicated in the figure. Determine the value of each of these currents. So determine I1, I2, and I3. We see 12 volt EMF source, so let that be V1. 6 volts EMF source, let that be V2. Let the 3 ohm resistor be R1 and R2 be the 6 ohm resistor here for current I2. And then for current I3, we have resistance R3, 6 ohms. Now, looking at the circuit, looking at the diagram of the circuit, we see two voltage sources, two power sources. That's an indication that we should use Kirchhoff's rules to analyze the circuit. And for Kirchhoff's rules, we have the junction rule and the loop rule. First, using the loop rule, we look at the junctions of the circuit. You have this junction and this junction. Looking at junction 1, we have current I1, I2, and I3 associated with this junction. Looking at the other junction, we see that the same currents are involved. You have I1, I2, and I3, which means applying junction rule on this junction and on the second junction will give us the same equation. So, we'll just use one junction in our analysis. So, just using the junction on the left, we get the following equation. Junction on the left, you have current I1 leaving the junction, so minus I1. You have current I2 heading into the junction, so you have plus I2. I3 is also heading into the junction, so plus I3 equal to 0. So negative I1 plus I2 plus I3 is equal to 0. Rearranging, we get I1 is equal to I2 plus I3. The equation that we get from junction rule. I1 is equal to I2 plus I3. I1 is equal to I2 plus I3. Now, there are three loops in the circuit. You have one loop, and then you have another loop, and then you have the third loop. You have three loops in the circuit. Using the loop rule and to be consistent, we use clockwise loop direction for all the loops. Each loop, one equation. If we use loop rule, we will get one equation for each loop. So three equations. Three equations together with the equation that we get with the junction rule, we get a total of 4 equations to work with. So again, we have the following loops. Let this be loop 1, and then loop 2, and then loop number 3. Applying the loop rule on loop 1, we get the following equation. Negative 12 plus I3 plus I2 times 6 minus 6 is equal to 0. Loop 1. First, the loop enters the negative side of 12 volts, so minus 12. Then, the loop passes through resistance 3 ohms. Voltage across 3 ohms is I1 times 3. The current is heading to the right. The loop is heading to the right, so same direction. So that gives you plus I1, 3 ohms. Next, the loop passes through the 6 ohm resistor. The loop is heading to the left. The current is heading to the left as well. So the voltage across 6 ohms, I2 times 6 ohms, IR. Same direction, the loop and the current. So that's plus I2 times 6 ohms. And then finally, the loop passes through the 6 volts EMF source entering via the negative side, the negative terminal. So, minus 6 volts. And the loop goes back to the original point. So, equal to 0. So, you have negative 12 plus I times 3 plus I2 times 6 minus 6 is equal to 0. Simplifying, we get negative 6 plus I1 plus 2I2 is equal to 0. Doing the same thing for the other loops, for loop 2 and for loop 3, doing the same thing for these loops, we get loop 2 equation, negative 12 plus I1 times 3 plus I3 times 6 is equal to 0. And loop 3, 6 minus I2 times 6 plus I3 times 6 is equal to 0. Simplifying the loop 2 equation, we get negative 4 plus I1 plus 2I3 is equal to 0. And for loop number 3, simplifying the equation, we get 1 minus I2 plus I3 is equal to 0. Now, using the loop 2 equation and combining it with the junction rule equation, replacing I1 by I2 plus I3, we get I2 is equal to 4 minus 3I3. Looking at the loop 3 equation and substituting the equation that we just derived into the loop 3 equation, so replacing I2 by 4 minus 3I3, we get I3 is equal to 3/4, which is just 0.75 amperes. Knowing I3, we are now able to calculate I2. I2 is equal to 4 minus 3I3. So replacing I3 by 0.75, we are able to determine I2. I2 is equal to 1.75 amperes. And knowing I3, knowing I2, using the junction rule equation, I1 is equal to I2 plus I3. Knowing I2, knowing I3, we are able to determine I1. I1 is equal to 2.5 amperes. So the currents passing through the resistors, you have I1 is equal to 2.500 amperes. I2 is equal to 1.750 amperes. And I3 is equal to 0.750 amperes. And finally, we have sample problem number 4. If the 3 ohm resistor is dissipating energy at the rate of 120 watts, determine the voltage V. We are provided the following circuit diagram. You have power supply, voltage V, which is what we are looking for. And you have 8 ohms, 3 ohms, and 6 ohms. You have 3 resistors connected in series. So let voltage V, which is what we are looking for, let that be V. And you have 8 ohms, let that be R1. And 3 ohms, let that be R2. And then 6 ohms, let that be R3. And the 3 ohm resistor, the problem tells us, is dissipating energy at the rate of 120 watts. Let that be P3 ohm. Power dissipated by the 3 ohm resistor. So P3 ohm is equal to 120 watts. Power dissipated by the resistor, we know the equation. There are 3 equations for power. One of them is P is equal to I squared R. Applying this equation to the 3 ohm resistor, you have P3 ohm is equal to I squared R2. R2 is the 3 ohm resistor, and I is the current passing through the circuit. The resistors are in series. Only one line, one current. So there's only one current flowing in the circuit. Let that be current I. Isolating I, we have I is equal to square root of P3 ohm over R2. We know P3 ohm. We know R2. We are able to calculate I2. 6.32455532 amperes. The resistors are in series, meaning their voltages will add up. So you have R1, voltage V1, R2, voltage V2, and R3, voltage V3. So V1, V2, V3. For resistors in series, the voltages will add up. V1 plus V2 plus V3. Total voltage of the resistors in series. Now, the resistors in series are connected in parallel to a voltage V. Thus, the total voltage of the resistors in series is voltage V. So, V is equal to V1 plus V2 plus V3. Applying Ohm's law, V is equal to IR. Applying Ohm's law to each of the voltages V1, V2, and V3, we get IR1 plus IR2 plus IR3 is equal to I times R1 plus R2 plus R3. We know all of these variables. We know I, we know R1, R2, and R3. Kompleto. Thus, we are able to calculate the voltage V. 107.517 volts. And that's it for our discussion on examples part 2. That's it for our discussion on simple circuits. So, thank you for watching.